So welcome to this lecture, Statistical Modeling. So this lecture is not going to be, it's not going to be long lah, okay? It's more to concept and understanding. I'm recording this lecture and I'll share the link for recording later. So first, when you do data analysis, you must, one of the things that you may want to think is about modeling. Especially when the objective of your analysis, of your research, of your project is about modeling, then, you know, if the project is related to modeling, then think about this. First, sekejap kita bagi Ihsan masuk dulu. Right. Okay. How will you deal with data from data to estimation? So so when you have data, kan, when you have data in modeling, what you want to do next is estimation. So you want to estimate perhaps the beta regression, for example, right? So after that, you want to estimate standard error, or maybe you want to estimate the likelihood value and other parameters. Okay. So when we mention estimation and when we work with general linear model or generalized linear model, GLM or generalized LM, the estimation means macam mana? Means the process of getting the parameters of interest. Okay. So so for example, like we did before for linear regression, we estimate the beta value for linear regression model. Then we did logistic regression. We also estimate the beta value for the logistic regression. And we also estimate the beta value or the regression parameter for the Cox proportional hazard regression. And after that, from estimation, we do some further analysis and to make inference. Right. So what do we mean by making inference? Usually it means getting the p-value and also the 95% confidence interval. Okay. So when I ask you to do estimation, just do just run the analysis, get the beta value, the standard error value. That is considered as estimation lah. You may want to get a R square value, log likelihood value, the Z value. Remember the Z value, standard error divided by the beta divided by standard error. Those are estimations. And when I say, okay, perform some inference, that it means get the p-value or the 95% confidence interval. Because now the interest is, because the estimation comes from your data. Inference is how would you infer or generalize the result to the population of interest. That's why you get p-value, right? And that's why you get the 95% confidence interval, because you are making inferences, right? And after that, if you get beta value from estimation, you get p-value and 95% confidence interval, it's good to move to prediction, right? Making prediction. So you make prediction based on your data, or sometimes you make prediction based on external data. For example, if your data contain value 10, 20, 30, 40, 50. Okay, 10, 20, 30, 40. Okay, for example, age, 10, 20, 30, 40 years old. And then I ask you, can you make prediction for someone age 35 years old? Right. So because it is not in your data set, so we are making prediction using external external data. Okay, external data or external value. Right. Right. So for linear regression, for linear regression, we will make the same prediction as the outcome. For example, if we are modeling the body weight, so the predicted value for linear regression will be body weight also lah, in kilogram, for example. But in logistic regression, when we make a prediction, we can predict the log odds, number one. And after that, we predict odds. And we can also predict the probability. When we make prediction for survival data from Cox proportional hazard regression model, we predict the log hazard. We can also predict hazard. We can also predict the risk of the risk compared to the average population. And sometimes, though controversial, we can also make prediction for the probability of the outcome. For example, if we do Cox proportional hazard regression where the outcome is death, so when we can predict the probability of death. But again, some people say you can do that. Some people say you cannot do that. And then after that, how will you communicate the models to the stakeholders, to patients, to your colleagues, to uh, your staff and whatnot? I think that is also important. That's why um, I hope you are comfortable with GitHub. You are comfortable with Posit Connect, so that you'll be able to reach a bigger audience lah. And if you are interested, maybe you can create dashboard, reactive dashboard. That would be very very interesting lah. So that people, so it'll be more impactful. If not, your finding will only stays in journals lah. Right. So next is, what is a statistical model? Statistical model is a mathematical model that embodies a set of statistical assumptions, right? So it is a mathematical model, but it has statistical assumptions. So these are the the assumptions that you have to make. So you can get power for your analysis by making certain assumptions. If not, kan, your analysis will always be weak lah. If, for example, like in the linear regression or in most statistical analysis, the assumption would be random sample. If you don't conduct random sample, then it means that your data tu, your model tu is not, or violate the assumption, right? Sorry, violate the model. So that's why even though you get data from registry, or you only conduct convenience sampling, but if you can assume that those data are basically uh, representing random sample of subject, okay lah, you know. And for example, if you do modeling for certain outcome, so you have to make assumptions of the covariates, right? If the covariates or covariate is a measure for stress, and you use DAS questionnaire, so you must be willing to assume that DAS questionnaire is a valid measure for stress. Okay, so uh, so when someone challenge you, then you have to be able to defend lah, and to say that these are my assumptions. It might be wrong, it might be correct, but based on my literature review, these are the valid assumptions for my analysis. Right. So right. So a statistical model represent often in considerably idealized form of data generating process. So model ni, uh, for example, linear regression model, right? When we write the equation, we always write equation like, for example, body mass or body weight equal beta 0 plus beta 1, exercise duration plus beta 2, comorbidity, and what so on and so forth. So why we use beta? Because the beta represent the true value, the true value in the population. But sometimes you cannot get the true value because you don't know, kan? So you don't know. That's why we perform estimation. The best that we can do is estimating the beta value. So that's why in the model we write as beta, but when we convert to equation, the beta becomes beta hat or just small b, right? Sometimes for us that's not really important lah, kan? Beta or b ke beta hat ke, kan? Looks like similar to us, but for some hardcore statistician they are different. Okay. For example, in the exam, kan, if I say write the statistical model, so you must write down beta value. Tapi when I say write equation from the analysis, so when you get the regression parameters for you, so when you write your equation, don't write beta. You write as B1 age, B2 sex, beta or beta hat. Right. Kalau markah tu memang rendah, I tak penalize lah. Kalau markah tu dah tinggi, I buanglah sikit markah tu, kan. So, right. Um, so a statistical model is a formal representations of a theory. So kalau if you want to model the factors for body weight, for example, what are the factors that contribute to body weight? So what would be your theory, kan? So you think that, okay, body weight for different people are different because it depends on whether you exercise or not, how long do you exercise, what kind of food intake, how many calories, are you stressed or not, are you blah, so on and so forth, So that is a statistical model, a formal representation of a theory. So it is not like, you have, okay, you have like, what, for example, you have only 5 variables, right? Sex, age, race, and then you said, okay, this is my model, because it is not very strong lah. A statistical model should be a robust and fully taught model. It's not simply that you say, okay, because I only have this 5 variables, this will be my model. Okay, you must also know what are other variables that you're supposed to add to your model, so that it becomes a robust model lah. Okay, Right. From the model, you can do statistical hypothesis to test, your hypothesis, and then you get the estimators for the statistical model. Okay, lah. And after that, from estimation, again, you go for inference. So from this few slides, I want you to remember, lah, okay, when you do statistical modeling, it means you got data. From data, you do estimation. Estimate what? Estimate the beta value, the standard error, the log likelihood, the R square, so on and so forth. After that, but that comes from the data. After that, you make inference because you want to know whether the estimation from your data can be inferred to the population of interest. So that's why you calculate the p-value and you calculate the 95% confidence interval. Okay, to make sense. Right. After that, you make prediction. And after that, you make prediction, right? So estimation, inference, and prediction. Okay. And then you communicate the findings. So yang tu, that will be the flow. Okay, that will be the flow. Right. So the model that for us, okay, because we are not doing mathematics and statistics, so the models that we are relevant to us are basically fall under general linear models and generalized linear model, right? So the one that we learn, linear regression, logistic regression, linear regression, for example, is a form of general linear model. Also, under general linear model is ANOVA and also analysis of covariance. ANOVA and COVA linear regression are basically under general linear models. So for general linear model, there are assumptions for them lah. Okay, but basically the model can be written as the value of y equal to the value of xb plus some random errors. U ni are basically error or noise. Okay. So y is basically a matrix of with series of multivariate measurement. X is a matrix of observations. B is a matrix containing parameters. Tak apalah ni. This one just a theory why we have this one. So this is a matrix or a vector of outcome. X and B basically a matrix of independent variables plus the estimated parameters. And then we have generalized linear model because we know that, for example, if we use linear regression for categorical outcome, for example, our outcome of interest is dead or alive. So we dead or alive, and in this case, we code dead as 1, alive as 0, for example. For example. So computer doesn't know that 1 is alive, 1 is dead, 0 is alive. It will say just that's number, okay? Number. So that's why when you have value of 0 and 1, you can run linear regression. Boleh je buat. Okay? Tak dapat error pun. Dia akan kata, you still got the parameters, the regression parameters values. But you know that, number one, the assumption of linear logistic regression is different because the outcome is binary. So it follows some kind of, it follows different distribution. It does not follow multivariate normal distribution. Okay, it follows Bernoulli, for example. So that's why you can't use general linear model. You have to use generalized linear model. Right. Right. So what else? And then generalized linear model also loosen this assumption lah, the multivariate normal distribution. Okay. So right. Apa lagi? So let's say if you want to try pun boleh kan. Let's say you have data with categorical outcome, yes, no, yes, no, yes, no, or alive date, alive date. So you run linear regression analysis in SPSS ke R ke, and then you try and check the residual. You get the residual, but the residual will not form multivariate normal distribution. It has it will form different type of distribution. Okay, so that itself is a violation of the assumption. Kan? So that's why we use other model. In this case, all those model falls under generalized linear model. Okay, so that's why I said this, because I want to again remind you that the choice of linear regression is this not because the outcome is continuous. The choice of logistic regression is this not because the outcome is binary, or the choice of multinomial it is not because the outcome is three categories or more. Because we choose linear regression because we assume the distribution of outcome given some covariates follows normal distributions. Why we choose logistic regression? Because we assume the distributions of alive and dead in our sample given sex, age, race follows Bernoulli distribution. Right. Barulah dia betul afdal lah. Afdal. Okay. Okay. Alright. Okay. So, and after that, okay. After that, for those who are going for FP lah, we are going to extend this model, the general linear model and generalized linear model into generalized estimating equations and generalized linear mixed models. That's why equation yang kita belajar yesterday, yang kita cuba practice yesterday, is quite important lah, because that can be, that can help you to understand better, uh, what we are going to learn next, which is generalized estimated equation and generalized linear mixed models. Right. Tapi this one tak masuk exam ya. Tak masuk exam sekarang. Okay. So, again, you have to ask yourself what kind of data that you have. What kind of assumption that you have to make for your data. Not just the outcome variable, but also uh, for the independent variables. What assumption that you have to make. You also have to assume the selection of sample. You have to also assume, if you take blood pressure kan, for example lah, you use ataupun baru ni kan ada yang Dr. Afiq apa ni, ada yang you all I think MPH ke yang apa ni follow satu kelas tu yang dia tunjuk apa ni how you can estimate the blood sugar based on capillary, right, without pricking kan, yang apa tu yang mampu buat kan. So the thing is that you have to make assumption lah, is that the alat tu is basically a valid tool to estimate the blood sugar. Okay. Right. Okay. Kalau dia tak valid, then you dah apa ni your model tu dah weak lah. Okay. And then what suitable the estimation, typo. What suitable estimation method to propose? What kind of assumption that you have to make? Can you infer your data to population? Look at the p-value, look at the 95% CI, and how good is the prediction, right? So when we talk about prediction, it also related to the observed data. So observe minus prediction, you got residual, right? Observe value, the real value, the outcome value of your data, the predicted value, you minus the two, you got the residual, right? From the residual, you can assess the residual to see whether your model are good or not. It means that whether the predicted value and the observed value are near or not. If they are far, then something is wrong somewhere lah. Ataupun your model tu is not good enough. And then sometimes there are observation that are the observed and the predicted value are very close. good. But in some other participant, the observed value and the residual, the observed value and the predicted value are very far away. So this, this scenario will lead to outliers and influential cases, right? So that's why when you look at your model, if your model is accurate, you still look at the individual participant, look at the outliers, look at the influential cases, so that you can do something to improve the accuracy of your model further. Right. Okay. Um, and then also think about whether you are doing hypothesis testing, estimation or prediction, whether you are doing prediction versus classification, or regression plus class versus classification. Are you doing confirmatory versus exploratory analysis? For example, if you are doing intervention study, intervention study, so and then you look at the outcome. So you are not going to do exploratory analysis because you already select, or you must include in the model or your covariate the intervention variable. Okay, right. And then what you need to do is to add other variable as controls. So you want to adjust, for example, okay, this is the covariate. Okay, so you study the body weight equal intervention plus all the other variables that you want to adjust. Okay, so that becomes confirmatory analysis. Um, you don't have to do you don't have to do variable screening ke apa, no need lah, because it's confirmatory, right? So there are also things you need to consider, includes variable selection, variable reduction, model validation, sample size, missing data, model assumptions, and how you deal with continuous independent variables. So in hypothesis testing, estimation and prediction, right? So again, statistic about study design, hypothesis testing, plus estimation, plus prediction. We know that, okay? These are the things that we have been doing. Prediction is when an area when analysts develop model that will accurately predict the response for future observations. If you are doing, for example, machine learning, machine learning or deep learning, for example, you are not interested to understand how independent variables are related with the outcome. Your interest is only prediction, right? Okay, statistical estimation is different. It is model based. So that's why in prediction, when you use machine learning, there are many machine learning algorithm or machine learning methods. Maybe hundreds of machine learning methods. And in fact, if you go to if you look at the large language model, it can be thousands of machine learning models lah. Tapi for statistical assumptions, not so many, yeah. Right. Apa lagi? Sample size. Sample size. I know lah, sample size kan, always an issue kan. For me, I used to pay a lot of time lah with sample size. Tapi sekarang ni, I think we sort of overemphasize on sample size lah. I think. Yeah, sample size I think is important, but it is not everything lah. It is not everything. So at least we know that if the sample size is too small, then it will not have good power for you to analyze or to make inference about your model kan. So that's the implication lah. Prediction versus classification. Right. So this one is another, I think maybe 7, 8 years ago. when you know about linear regression, logistic regression, Cox proportionalized regression, okay lah, enough lah, you know. Tapi now, I think you know about machine learning kan. So people are talking about machine learning kan, deep learning lah, you know, chat GPT lah, large language model lah, you know. So, so what are they talking is about this lah, you know, prediction using machine learning, for example. So, so if you have time, then you know you may want to apa ni to learn about machine learning, especially when your your interest is just making prediction. You are not interested to explain why sex affect BMI, why exercise affect BMI, how exercise will interact with BMI, how exercise will interact with sex, for example. You know, you are not interested in that. Your major interest is just to make prediction. Okay, right. Okay, problem with statistical modeling. Kenapa ada add comment dekat sini? Okay, tak ada. Problems with statistical modeling. Process of generating is not stable. Apa maksud dia? Tak faham juga. Tak apalah. Model is misspecified. Okay, we talk about this quite a number of times. Model is misspecified. For example, non-linearities. We did not spend much time lah for linearities assumptions because we you know we don't have much time, enough time for that. But yes, it is important non-linearities. So for logistic regression, for Cox proportional hazard regression, there are assumptions of linearity in logics and linearity in hazard. Okay. Um, tapi tak apalah, okay. Tapi kalau keluar exam, if you were asked state the assumptions, then you know one assumption that you need to write is the linearities of logic and linearities of hazard. Interaction, okay. If there are interaction, but you did not include, but you don't include or you did not include in your model, that is also misspecified. Okay. Um, for MPH, okay lah, you know, you can get away with that lah, you know. You say, okay, my model ni does not have any interaction. Walaupun you tak provide any evidence of that, you know. But in the RPH, I think, when you write your apa ni, your model tu, when you analyze your model, try to look for interaction. Interaction is interesting, okay? Interaction is interesting. And then missing predictors. What are other predictors that you should have include in your model to improve the accuracy of your model, kan? So you cannot say, okay, oh, I've got 5 variables and then at the end, I only have 2 significant variable in my model. As if other variables are not important. Padahal you did not have that variables, kan? So, you know, so you need to be able to tell the, you know, the reviewer or the examiners that, you know, there are other variables that might have influence in my model. For example, this and this and this based on this literature, but, you know, because of, you know, limitations, because of the, uh, you know, um, uh, you know, the registry does not have that, you know, so that basically I can't model that lah. Tapi it shows that you have that you are thinking lah, you know, you are thinking lah, you know. Alright. Apa lagi tu? Model is misspecified lagi. Transformation of dependent variable and model distribution assumption. If your model, for example, if you use if you perform linear regression and there is non-linearity, should you transform or not your dependent variable? Right. You can transform the independent variable or you can transform the independent variable. Tapi bila you interpret, yang tu jadi pening kepala sikit. Right. Okay. Tapi I will not go to that lah. Tapi you can do transformation, but when you interpret, you cannot interpret like normal lah. You have to interpret using the transform variable. Hmm. Okay. Model contain discontinuities, for example, by categorizing continuous predictors. Okay, this is when you have a numerical variable. Should you categorize or should you not categorize? Correlation. Correlation among subjects are not specified. Okay. Um, this is especially true when we do modeling where the assumption is independence between observations. Okay. So if your data, for example, if we take data from school, kan, 20 school, and then from each school you take 100 students, data from 100 students, and then after that you go and you do linear regression analysis. Padahal you know that in linear regression analysis, the assumption is that there is no independence between observations. But you also understand that kalau student datang pada sekolah A, dia punya there is high correlation between them compared to student in sekolah B. Sekolah B will have their own correlation. Sekolah A will be highly correlated among themselves. Sekolah C will be highly correlated among themselves, right? So, so where is the assumptions of independence? Alright. Tapi tak apalah. For before this, okay, we accept that. But for the other page, when you analyze data, for example, from different school ataupun different clinic kesihatan, for example, right? So people or me or I might ask, okay, why you do linear regression? Why you do logistic regression? Why don't you do mixed model? Because your data might not be independent. Inefficient parameter estimate over confidence inference. Model is overfit. When your model is overfit, your model will overfit bila mana you have too many independent variable. You include everything kan. So mentah-mentah lah you cakap Dr. Kim kata okay, don't depend on p value, you include everything in your model kan. 20 covariate, you put all 20 covariates in your model. So that will also lead to model overfit. So macam mana ni? How to decide between too many covariates and too small covariates? Itu I pun tak ada jawapan. Sorry. Making predictions by using out of range predictor value. This happen when if for example in your data set the minimum age is 40 years old and the maximum age is 70 years old. So you cannot make prediction for someone age 80 or for someone age 20 years old. Okay? So when you do, for example, a risk calculator, for example, because now you say, oh, I know, I can now make calculators. Janganlah buat calculators yang umur 20 years old and umur 80 years old when your data only contain people from 40 years old to 70 years old. Okay, so that's what you meant by out of range predictor value. Emphasizing continuous variable. Again, the hardcore statistician will always say that you cannot. Tiga kali cakap you cannot categorize continuous variable, right? Because when you categorize, your selection of cut-off point to a subjective. And then when you cut off the value, you dah lost some information. You contain less statistical information. And then at the same time, dia apa ni? If it does not lead to, it does not reduce any measurement error. You still got that measurement error. So if I wear a statistician head, I will always tell you that don't categorize your continuous variable. Tapi we are always faced with situation where people or our friends lah, our clinician, physician, they always ask, okay, what if the BMI this category? low BMI, normal BMI, overweight, you know, what would be the risk if someone is, is overweight, someone is obese class 1, class 2, class 3 kan. So kalau macam gitu, as if you need to categorize kan. So I also in dilemma. Okay, so which one you want to follow? Okay, you have to think lah. Missing data. There are three types. Actually three type missing data. One is missing completely at random, or MCAR, missing at random, MAR, and informative missing or missing not at random, right? So missing completely at random is basically you go and you take questionnaire, and some people, sometimes they forgot to answer this question, sometimes they forgot to answer that question. So that is considered as missing completely at random. Missing at random is not completely at random lah. Dia random juga tapi dia tak completely at random. Contohnya, if you ask about income, okay, for those yang income maybe too high or maybe too small, they decide that, oh, I don't want to answer that question lah. So they do not fill the information for that question. Tapi for other question, they answer. So that is considered as missing at random. Not completely at random, just at random. Okay. And there's another one is informative missing or missing not at random. Missing yang missing data yang happen due to the outcome of interest. For example, if you are studying cancer death, and then you ambil data survival, and because of this side effect, or because of the effect of cancer or side effect of drugs, cancer patient passed away, died. And for those who died, they did not, contribute data to your study kan. So data from those who died, for example, in that situation, is considered as informative missing or missing not at random, because it is related to the outcome of the study. Um, in our book, there is a chapter on missing data. So Hanis wrote that chapter, so you may want to look at it lah. Okay. So missing completely at random, missing at random. So these two missingness are ignorable. Ignorable. It means that when you have this kind of data, you still can analyze. Okay, you still can analyze. Tapi if there is informative missing, this is considered as non-ignorable or missing not at random. So in this case, you cannot ignore that missing data. You have to do something. Right. Okay. So when you have missing data, what you need to do? You can do imputation. So in your presentation kan, masa MPH, or maybe later when you present your proposal masa DRPH, you will say that, okay, if I will drop any variables that have missing data bigger than 20%. I think now you don't have to say that lah. Okay. So don't drop any variables that have missing data more than 20%. In fact, if data is missing for up to 30%, 40%, you still can do multiple imputation or imputation. Right? Tapi itulah you kena bersedia dengan soalan daripada your friend ke daripada lecturer. Dia kata, kenapa? Bukan kena remove variable if the missing data is more than 20%. Okay, now you must be brave enough lah to say why you don't have to do that. Okay. Tapi the basis of that is that if you have missing data, 10% of that variable is missing, or 20% or 30% or 40%, you can do a procedure called imputation. So you can do a single conditional mean imputation. It means that you replace the value of missing data by the average value of that column. Tapi this one is very old method lah. Usually, so we will not accept lah this method. Okay. Number two, you can do predictive mean matching. And number 3, you can do multiple imputation. So the best method is multiple imputation. So again, single conditional mean imputation is easy. It means that if let's say you have missing data for age, right? Age, variable age. What you need to do is just you take the value of the mean value for the age, and then you just replace the missing data for age 2 with the average value or the mean value of the age. Again, that is the very crude method lah. Usually we will not use this. Right. Predictive mean matching, it means that if you have missing value for age, right? You have missing value for age. You use other variable in your data set. For example, gender, sex, BMI, serum cholesterol, blah blah blah, and then you use this information to predict the best value for the missing value for variable age. Right. So it means that you use predictive mean matching. Okay. Right. So usually in predictive model you use the outcome. You even use the outcome variable pun. Okay, you use the outcome variable plus all predictors in the final outcome plus any other auxiliary variable, and then in this case the outcome variable is variable age. Variable age. So now you can make prediction what would be the value of the missing value for variable age using information from outcome variable and all other predictors in the outcome plus any other variables. Right. The best one is to use multiple imputation. Right, multiple imputation. So you have one data set, right? And then what multiple imputation will do is that it will generate like 20 data set or 30 data set of maybe 100 data set. And then after that, it will average the value of variable age, for example. So now the missing data of variable age will be replaced by a hypothetical value of variable age based on multiple imputation method. This is the what we call the best method lah for replacing missing data. All right. Next, the issue of multi-variable modeling strategies. You have to think about whether you want to have a parsimony model or complex model. Okay. So if your model is parsimonious and fit, and there's another model which is very complex but also has the same adjusted R square, for example, why you need a complex model? Can use the simpler model. Okay. Parametric versus non-parametric model, parsimony versus good discriminatory index, and interpretable model versus black box model. Okay. So for example, if you want to make prediction, your interest is to make prediction. For example, you are not interested to see confounders ke, interaction ke, uh, relationship between covariates ke. Your interest is only prediction. You can use black box methods, for example, machine learning. But if you want to interpret your model, you may want to use statistical model, for example, GLM or generalized linear model. Variable selection. There's always a belief lah, you must include only significant variables. Again, this is false belief. Kepercayaan khurafat. Okay, khurafat untuk mempercayai bahawa only independent variables yang significant saja perlu ada dalam model. Okay. Stepwise. Stepwise is common. Stepwise is common, right? You do stepwise, forward stepwise, backward stepwise, automatic stepwise. Because because the analysts claim that you can develop concise model, it can reduce collinearity, And then you don't have to think lah, you don't have to use your brain, you just let the computer do the thinking for you kan. Tapi authors have agreed that stepwise selection, the implication that it violates every principle of statistical estimation and hypothesis testing. Berat tu dia punya tuduhan kan. You know? So stepwise selection violates every principles of statistical estimation and hypothesis testing. So itulah salah satu saya punya misinya adalah untuk mengurangkan kebergantungan kepada stepwise variable selection. Okay. Walaupun dulu pun saya pun ajar juga stepwise selection. So kalau tengok dalam satu website, if you Google kan problems with stepwise, you'll find a very good discussion in Stata punya mailing list lah. So basically, a statistician ada, they discuss about this and they are well-known statistician lah. So they say that if you do stepwise, you can get, high R square value, but the R square value are basically biased. Okay. And then the F and chi-square test do not have the claim distribution. And then it will give you a low standard error and small CI, and also narrow predictive values that are not valid. Okay. And you get very small p-value. Of course, this is good news lah kan. You get very small p-value, right? Tapi the p-values are biased. Okay. And you provide regression coefficient that are biased, that are bias high, that are highly biased. Okay. And then it can result in residual confounding. It made arbitrarily by collinearity. And then last thing they say, it allow us not to think about the problem. Maksud kita tak guna akal kita lah. Kita menggunakan akal SPSS untuk berfikir bagi pihak kita. Ini bukan saya cakap. This one, if you Google, you'll find this, alright? You'll find this, okay? In fact, Frank Harrell, and then a few more statisticians, they discuss about this, and these are basically the the findings lah they got from their discussion. Selepas ni jangan guna lagi lah stepwise kan. P-value 0.25. Lepas tu saya akan pakai forward stepwise, backward stepwise. Okay. Right. Right. Data reduction, tak apalah. Ini boleh forget. And then this problems with p-value. So this is the, orang kata, one of the moment lah where can we totally reject stepwise? I think so. Yes. Reject stepwise. No need, okay? Tak payah guna stepwise dah, okay? Right. Don't use stepwise anymore, okay? Problem with p-value. This is one of the the hallmark statement lah where it create stepwise is one of the method to evaluate confounders. Not really lah, Nella. No need to do that, okay? Okay, this is one paper that I think you can read. It's very good, and then it's very good, and there are a lot of papers after that comes out because of this. So this is the American Statistical Association statement. Okay, bukan calang-calang lah. This is America's Statistical Association's punya statement on p-values, contact per process and purpose. Mana dia cakap dia cakap adalah something nanti baca this one, tapi in short they say that don't use p-value lah, which is quite radical lah. Don't use p-value. They say no, don't use p-value. And in fact, after that, there are, papers from a team that support this. But there are also papers that yang tak berapa setuju dengan this one lah. Uh, Especially daripada saintis nama Ioannidis pun banyak buat paper pasal COVID-19. Dia ni macam apa ni? Macam epidemiologis yang banyak buat kerja dengan medical lah. You know. So, tapi a very good discussion following that, okay? Overly influential observations, and again, always check for influential observations because sometimes you got too few observations. Your sample is very small. Your study sample too small sangat kan. So, tak bagus. So, you dapat influential observations. Sometimes because you make data transcriptions or data entry error. So, always check this. And then sometimes you got extreme values of predictor. Sometimes kan, you pergi sample someone and maybe you ambil IQ kan. Dia punya IQ lebih pada orang lain kan. Dia punya IQ 200 kan. Kita punya IQ berapa? 100 kot. 100 tinggi ke IQ? Around that lah, okay? Tapi dia punya IQ 200 kan. Ataupun dia punya um, something too large kan. Jadi because of that dia menyebabkan apa ni data tu jadi extreme values and may affect your model. So be careful about influential observations. Alright, this one is not that important. Model development to select covariates. So macam mana kita nak buat nak select covariates? So you can use a method called purposeful selection. Okay. So kalau you tengok Hosmer-Lemaitre kan yang you selalu, bukan you lah, maksudnya yang selalu kita dengar kan, maksudnya okay, choose p-value less than 0.2 and then from there do buang variable yang tak berguna, dapat make effect check interaction and all that. That is macam purposeful selection lah. Okay, I rasa dia tu datang daripada buku, daripada Hosmer and Lemaitre. I think Hosmer and Lemaitre proposed that purposeful selection. Dia tak cakap stepwise tau. Dia tak buat stepwise automatic tau. Dia cakap purposeful selection. Tapi of course lah ada stepwise selection. So forward, backward or stepwise selection. Masih juga ada. Okay, walaupun hopefully kita boleh kata tak buat lah, tak apa stepwise. After this, okay, you can forget about stepwise. And best subset model and multi variable fractional polynomials punya method. Okay. This one dalam our book tu, the last chapter tu we talk about what are some of the variable selection and some of the model development procedures lah. Okay, so boleh juga baca book chapter yang last sekali ya. Purpose selection pula. Purposeful selection, okay. Yang ni fit multivariable model and then add choose clinically important variables and then blah 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 blah. Okay, boleh lah because this is not entirely stepwise. Okay, this is not entirely stepwise. Even dalam ni pun, dalam Hosmer Lemaitre, dia tak cakap pun stepwise sebenarnya. Dia cuma cakap okay, daripada tu understand and then remove, and once you remove, you check other variable macam mana dia punya effect kan. Right. And then you get the main effect model and then you check interaction. After you check interaction and some other you keep some other interaction that is significant or significant ataupun interaction yang not significant but you want to keep in the model, that is called as preliminary final model. Not preliminary model but preliminary final model. You do model evaluation or model assumption. After that, barulah dia consider as final model. Alright, thank you very much. Itu saja. So, berapa minit? 4 minit, pukul 4-8 minit. So, on time. 1 jam. Cukup. So, any question? Any question? So, kita tengok chat box apa ada. Mana dia punya chat box eh? So, right. Okay, oh, ada juga soalan. Okay, from categorical boleh buat imputasi tak? Kalau categorical variable boleh buat imputation tak? Yes, even though your covariates to um, apanya categorical covariates, and then they have missing data. For example, like for example, you have independent variable stress kan? Stress, not stress, stress, not stress, stress, not stress. And then there is um, missing value for that variable. Yes, you can do multiple imputation or even for categorical variable. Can we totally reject stepwise method involved in the model? I think yes lah. I think you can reject lah. Not totally lah. Maybe 95% of the time you can reject lah. Okay. Right. But stepwise selection method is one of the strategy for evaluation confounder. This one, I think Nella is not that accurate. I think how to evaluate confounder is confounder is really, you kata, confounder is okay. Number one, you kena fulfill tiga kriteria for confounder kan. Dia maksudnya Z cos Y, Z also cos the X, and then apa lagi? Z is not the mediator, and one more is tiga benda tu kan. Lepas tu, statistically how you do this? Statistically, bila you buat model kan, katakan your model tu ada A, B, C, A, B, C, A, B. Kata dia ada A, B kan, variable A, variable B. So, you pun masuk variable C dekat dalam model tu, and then you tengok how big variable C change value of variable A and B. Right. Kalau dia change more than 20%, more than 25%, dia change the variable tu, it means that C tu, it means that C might be a confounder. Right? Interaction, kalau kita baca buku Hosman Lemon Shopper, dia cakap interaction ni usually kita look at p-value. Maksudnya kalau kita set p-value at 0.05, kalau like interaction tu less than 0.05, we keep. Kalau dia bigger than 0.05, we kick it out, okay? Buang dia. Tapi confounder is not tested by p-value. You don't use p-value to assess for confounders. Faham eh? Semua boleh faham tak? Very important kan this one, okay? Boleh faham semua eh? So, p-value, apa ni, confounder is not assessed by p-value. Or you don't assess confounder by p-value. You assess confounder by theory. Number two, you assess the confounder by looking at how much that assume confounder or that variable yang you rasa confounder tu, how much it will change the value of other covariates, the beta value for other covariates. So that's why, kalau lagi cantik lah kan, you ada satu model yang tak ada confounder tu, you tengok beta value, and satu model yang ada confounder, and then you compare beta value antara dua tu, how big the change in the beta value. Kalau change to more than 20%, then you may say that variable C tu is an important confounder. So, bila dia merubah value of beta for other covariates more than 20%, you want to keep that. You want to keep variable C in the model. Okay. Confounders, you mau simpan. Interaction, you mau buang. Okay. Okay. Confounders, you mau simpan. Interaction or effect modifier, you mau buang. Confounders, you check with theory, which change in the beta value. Interaction, you check with p-value. Right. Right.
Oh,
Ah,
macam ni,
betul.
ada satu soalan. Contohnya, sebabnya kalau interaction ni, kita access by the p-value. But p-value tu is not so much lah. Contohnya kita ambil 0.049, 0.045. Maknanya kita nak, macam mana tu? Kita nak handle that kind of interaction. Sebab
Ya,
adakah
ya.
kita betul ikut p-value ataupun kita ambil yang pernah kata, p-value ni sekadar kita punya panduan je lah.
First kita nak check interaction. First interaction tu, bila kita decide interaction tu, katakan interaction antara age dengan diabetes kan. Diabetes yes, no, age, old, young. Jadi yang tu, siapa yang decide interaction tu? Ada dua cara. Sama ada exploratory, maksudnya you ada tiga model A, B, C. So you pun buat interaction antara A, B, A, C, B, C. Boleh juga satu kan. Yang kedua, you dah decide, okay, I ada variable A, B, C, tapi interaction yang make sense hanyalah interaction antara A dengan C saja. Right. So in that, which is simpler lah. Okay. So you pun buat interaction AC, you masuk dalam yang model, and then you also kena decide masa dekat situ sama what is the cut off value for what is the cut off value for p value, sama ada 0.05 or 0.1 or 0.2. Again, bukannya magic number for interaction tu you nak keep ataupun tak. It is not that the p-value must be less than 0.05. In fact, kalau you baca buku Hosmer Lemon Show, ada satu example yang mana dia keep interaction tu walaupun p-value tu, the p-value of the interaction in the model tu adalah 0.1, bukan 0.05. Tapi because dia kata dalam methods tu dia nak keep interaction pada value 0.1, dia keep lah. So, untuk jawab your soalan, you as a researcher can choose whether you want to use 0.05 or 0.1. Depend. Right.
Prof, nak tanya sikit tu. Yang tadi boleh pilih sama ada 0.05 ataupun 0.1 kan? Kalau apa kita punya explanation tu, kita decide sama ada kita nak pilih 0.05 ataupun 0.1 tu. Yang soalan selanjutnya daripada ni lah. Examiner
Okay. Sebab apa ni, confounder ni dia pada teori kan, teori. Tapi interaction ni lebih kepada exploratory lah. Maksudnya, bila you dah buat model kan, the next step is you want to explore. Mungkin ada interaction lah, code. So that's why, apa ni, uh, tapi confounder ni pada awal lagi dah decide, oh ni memang betul ni daripada literature review, memang this variable confounders dah decide awal-awal. Dan for interaction ni, usually dia lebih kepada exploratory. Dia kata macam nak melengkapkan your analysis lah. You buat dulu you buat variable selection tu, lepas tu you tengok mungkin ada tak interaction yang penting. So that's why so it depends lah, nak maybe it's prerogative of the researcher tu untuk letak p value tu berapa, 0.05 or 0.1. Saya pun tak ada kata alasan lebih daripada tu lah. Kita bagi 10 saat. Kalau tak ada soalan, kita boleh adjourn. Right. Suhana tepuk tangan banyak kali dah dia.